Hello, Francis. How are you?
Hi, Shayu. Yeah, I'm fine.
Hi, everyone who are joining up, right? Welcome to our third workshop, right? That is more focused towards the integration of blockchain with artificial intelligence, right? How you can leverage ICP, right? And when it comes to ICP blockchain, right, it is as a tech architecture which can be used in AI, right? And we have special grants as well, right? To the tune of 5 million US dollars, right? For projects who are using AI and ICT, right? So there is a huge opportunity, right? That can be leveraged upon, right? And we have with us our dev mentor Francis here, who will be guiding us throughout this entire period, right? How we can use and leverage ICT tech stack in building AI applications, right? So welcome, Francis, right? Over to you, right? Please start, right? I think more and more people will keep on joining.
Okay,
Yeah.
sure. I'll start. Let me share my screen. And okay, okay. Can you all see my screen, everyone? Okay, good. Okay, let's start. So, all of you here has been attended my previous section, right? Anyone? Anyone? This is the first time attend this workshop. Maybe you just put a message say one. One means you are the first time. Okay. Okay. Maybe you can refer to my pre-record video the first time so that you understand what you need to prepare how to kickstart the development of using the ICP blockchain and the tools that you require to install. Okay. So it's the same as those you are new. Actually, you need to have some prerequisite. So later, if you have time, I will explain over again what you need to prepare so that you can start the development. If you are using Windows, all those, unfortunately, all the development related with ICP smart contract, you need to have Linux environment or Mac OS environment. Means if you are using Windows, that means you need to install the WSL, Windows Subsystem Linux, so that you can continue the installation of the ICP development toolkits. Because the ICP development toolkit DFX only work under Unix environment. Other than that, you will need Node.js and GitHub because you need to manage the source code. You need to download some code all from the GitHub. So you need a GitHub and Git. And because today we are talking about AI. So any of you heard about Hugging Face, or any of you have already has experience doing some AI development? I means you do AI development without not talk about using ICP. Basically, you example like you build your own models, or you host the AI models, LLM models in your own premise. I'm not talking about you are using ChatGPT or you using Claude Sonnet. How many of you already has experience of development by using implementing AI? Any of you? Okay. So normally when we talk about AI development nowadays, everyone basically is talk about Gen AI, talking about large language models. because ChatGPT make it very famous, so that a lot of big corporation also start to look into this area. OpenAI has ChatGPT, Google has Gemini, right? Then like Twitter, X, they also had Grok, all this. Everyone has been rushed into building a huge centralized kind of a AI solution provider. Other than that, also some others corporate also releasing their own open source model, open source AI model, which allow you to use their model. That means you can download their models and you can use PyTorch, transformer and tokenizer to run those open source model and host that LLM model in your on-premise, means in your own server, all this. So basically, Hugging Face is the, I would say Hugging Face is a main place where you can find a lot of different open source model, whereby you can download it, then you can build your own application using those open source model. Since today we are talking about decentralized AI, that means you also can using those open source model and run it as in canister in ICP. Later, I will show you some tools, all this that how you do it. Because in open source AI model, there will be many different type. It can be a neural network, it can be LLM transformer. So that, and the AI model, it can be used for different purpose, like image processing, face recognitions, voice recognitions, and several type. And the latest Gen AI talking about large language models, or like based on your text prompt, generate image, all this. So for the development related to AI, the programming language you need to know, there's two programming language I believe you must hands-on. That means you are using Rust and Python a lot. Because now a lot of open source AI, all these, especially LLM, they are using PyTorch and a transformer architecture, which invented by Google's. So if you want to have this slide and you haven't joined the Telegram group, please join the Telegram group, and another QR code, all this is for you to download this presentation slide. Okay. To have Rust program language installed in your operating system, please do open your Linux terminal and execute following command line, and then make sure the Rust is successfully installed. So this is one of the requirement for today workshop, so that you can test it out. Because a lot of other than Python, because Python is mostly used AI in AI development. Other than Python, there's a lot of then the second programming language will be used in a lot in AI development will be Rust. So there will be actually there's a lot of AI engine has been developed by using Rust. So since ICP Internet Computers, they support WebAssembly, and the smart contract can be developed by using Rust programming. So it makes it much more easier to port the existing machine learning framework written in Rust and make it compatible to execute it in ICP canister. So that's why Rust is very important. So why we talk about decentralized AI. Why decentralized AI? So decentralized AI normally is the intersections between AI and blockchain technology. It's referred to an artificial intelligence running on a fully decentralized and secure platform. Why we need an alternative compared to like ChatGPT, OpenAI, all those? Because there is one problems that because of centralized AI. Because when centralized AI, we do not own the data and there is no transparency, whereby we don't know how do those centralized AI service provider use our data. They can base on our data, they can take our data to train their models, and it may have some privacy issue. Because once the data has our own data accidentally trained into those centralized AI, it is very difficult for us to request to remove our data from that AI models. So that is where the alternative, we should look into decentralized AI. What can we do with decentralized AI? Number one, data sovereignty. User maintain control over their data. Because through blockchain is transparent, so that it can ensure privacy and ownership. Open models. AI model can be shared and accessed in decentralized manners. That means, as in decentralized, everyone has knowledge how to train and build the models. They can train their own model and build a model and publish in decentralized way, like into ICP has a decentralized AI marketplace. Anyone can publish so that it can be shared and collaborate with any peer without any central control. Because as in decentralized way is transparent and open. Enhance security. Since as in ICP blockchain has maintained multiple nodes, so that when running AI application, it reducing risk associated with centralized server. And it has no single point of failure because that is decentralized. Multiple nodes will have the AI models running. Then it provides a redundancy features. Smart contract. Developer also can use smart contract that automate process and decision making using AI. Scalability is allow us easy to scale up our AI application. As like in ICP, each of the canister you can access to 400 gig permanent storage, so you can easy to store multiple AI model in multiple canister. It is so easy to scale up. Basically, you just need to deploy a different canister to run different AI model, so that your DApp applications which use AI can connect to multiple canister and using different AI model for your specific purpose. That's why we want to use decentralized AI. Because user has to blindly trust AI running on the centralized server, which like ChatGPT, they have no visibility into how their data is used. Correct? Do you know how OpenAI use your data? And how AI model produce response? Are they work correctly, reliable and consistent? Today, ChatGPT give you this response. Next time, what are the response, because you can't respond, you won't know, because it's all depend how OpenAI, where they grab the data, how they train the data. You have no visibility on that. So that's why there's come decentralized AI, transparency. All the training, all this will be transparent. Basically, it will be recorded in the blockchain. Collaboration and innovation is allowed different scientists or even a researcher, private researcher, to collaborate together without need to grant access from a centralized service provider. You yourself cannot contribute to ChatGPT AI model, right? You need to become the staff of OpenAI. Then you only able to access and train the ChatGPT models. But with decentralized AI, anyone has shared the similar interest can form a group and start train and build your own AI models. After that, you can publish through ICP blockchain to let anyone know, then to let others to use your models. Okay, when we talk about AI, there's a lot we heard about inference. Inference in the context of decentralized AI refer to using is the process of using trained machine learning model to make prediction and decision based on input data. That means when you want to communicate with whether decentralized or centralized AI, normally nowadays we talk about prompt engineer, how we send the prompt into the AI engine so that the AI will process your prompt and respond back the output data. Throughout this process, actually is called inference. So during inference, the model apply what it has learned to analyze real-world data and generate output. So as in decentralized AI, in the context of ICP, means we are submit the prompt into the canister smart contract. Then it depends the model running in the canister smart contract, how it process the data and respond output back to the user. Other than that, we also can utilize HTTPS outcall. That means you may not need to have the whole model in the canister. You still can use HTTPS outcall to connect to the others AI service provider through API to send the prompt and retrieve the prompt back into the canister, whereby then you use the smart contract function to store the response, make it as to keep track of the interaction history in the transparent way. So there will be several type of AI engine has been successfully implemented as in ICP canister. Number one, we call Sonos Track. Track is a neural network inference engine written in Rush. Support TensorFlow and ONNX NNEF inference model. ONNX model right now is widely used in web AI. That means now there is a lot of AI engine able to run in browser. They are using ONNX model formats. And also a lot of Rush AI engine supported ONNX format. A neural network is a type of artificial intelligence. It's widely used in image recognitions, speech recognitions, autonomous vehicles, predictive analytics, healthcare diagnostic, recommendation system. So actually, it has been widely used in our life. Example like Facebook posts, Amazon e-commerce, how they study our behavior. Those websites study our behavior and always show us type of products, type of the post that we like. So in behind, basically they are using neural networks, AI. So Sonos Track is able to do so, is able to run this type of models. Because it's written in Rush, so that it is very easier to port and run it inside ICP canister. So here ICP actually already prepared, has some demo, whereby using Track to perform the task like face recognitions and image classifications. So I can bring up samples to explain how it works. Okay. From here, actually, you can download the sample source code, the example source code, face recognitions. Second is image classifications. Here. Okay. Let me explain the code so that it's much more easier for you. Okay. Okay, let me start with image classifications. Let me start again. The local replica. Okay, image classification is using the track engine. Let's see. Okay, so this is there's a back-end code and the front-end code. So if you're familiar with Rush project, so you always look at the cargo package. So you see they are using the track ONNX. And since this project also use the file system is using WebAssembly system interface, but as in Canister has no file system, whereby it require a polyfill. That means with this polyfill, it will replace the file system with some ICP canister own storage. So normally when you want to emulate a file system in a canister, you are required to have this, to include this package, OC polyfill. And another type is, and you need to install, later I'll show you, you need to install this WASI to IC. That means after you build your backend canister, the WebAssembly, you need to convert. That means you need to convert. That means these tools will replace all the WebAssembly system interface functions like file system into the ICP emulate function so that your application won't crash when it runs inside a canister environment. So how the implementation, the image classifier, how's the implementation? So you look at the source code. So there will be a ONNX-RS. This is how to use the track ONNX. So you set up, it load the models. Then this is actual the classify function. That means when the front end upload the image was sent into this smart contract function, classified. After that, it will return the result. This image classification type. So the current sample demo has been trained with this 1,000 label. Example, Tash, electric ray, stingray, all this 1,000. The current sample models. So whatever is submit to here, it will return. So this is how the image classification work. Go. Okay. Wait me. Okay, so there's a README how you install the DFX tools, all this, install the vaccine to it. Yeah. So I reinstall everything that's required. Build. So this is how the build file. So that means when you build the backend, all this, you'll see the build function. You always call this build sh. So when you want to implement an AI example by using this track, so this sample you may need to follow certain structure. So you always, when you build the backend canister, you always need to do certain conversion by running this. So let me run since I already have all the tools, you got download models. Another one, download model is using a very small model. Using a very small model, you download from here ONNX model, it called MobileNet V2. So this is for image classification purpose. So you can go to this URL. Actually, you can go to these URLs and find others. You can try other models also. Because there is a lot of sample models in the ONNX model. So it's the vision classification MobileNet models. So you're using this. So I already download the models. Actually, I already download the models. So you can download the models. So you download, you will store in here, backend asset. Backend asset. So this is a model. So how to put the model? Since this model is not that big, how to put the model into the canister? How to put it? See. Yeah, ImageNet. You use the include byte function. That means during compile time, it will load the whole model content as the byte, as everything content. Compile time load everything statically link into the WebAssembly. Means it will include all the model content in the WebAssembly codes. So once you have all, if you follow the README, all this download, you have this, then you just running. Okay, running. So I just deploy. So you're creating the So you see, when I build the application, I will include the vaccine function because we are using in our model using some system interface. Some system interface. Yeah, you take some time to build the rush. This is to showcase how you do the inference on chain. This is an example. You can load the full model in a WebAssembly. Later, will be have the face recognition will have another method. That means you deploy your canister first, and later you only upload the model into the canister. This image classification, when you compile, you already include the model in the canister. So at the end, it depends how you want to build your canister, which run the AI engine. Because when some of the model is bigger, example few hundred megs, you may need to choose other method. That means you deploy your canister first with the AI engine. Later, you use the upload tools to upload the AI model into the canister. It takes some time. Okay. So you can see all the dependency. So you start converting. Okay, now it's the front end. So front end will be taking care of sending the image to the canister to execute the classified functions. So link file will be always the the entry of the canister. And you can check the expose interface will be DID. So you expose three functions: classify, query, and run. Okay, done. Let me open the browser. Okay, so the front end already running. Then you can choose the image, desktop. You can choose this, open, go. So it will return classification like goldfish, how many score, rock beauty, how many score, mercury. So those are the trained data. Means they classify. Yes. So you should able to search goldfish. Yes. Goldfish is here. Right? Then upload another one. Yes. So yeah, volcano apps valleys. So you're able to detect certain pattern. How about apples? Oh, yeah, I cannot come out apple. Why? Because in the models has not been trained with apple. So it has pineapple, there's no apple, and custard apple. So that's the reason the models cannot classify apple. So it classifies others. So the performance actually is based on the model that we use, based on the model that we train. So this is the model, the sample, how you fully run the AI models on chain. Because because the front actually is calling the smart contract, the canister, sending the photo into the canister and using the ONNX engine, track ONNX engine to process the image, calling the classified, process the image, and return the score and the label. You return 3 score and label. So this is how the image classification work. And you can check all the track website and see what are the how you use track. You can check the almost. Yeah, there's also provide some samples. All these, then when you try to build your different AI that try to implement in Canister, basically you can also refer to track and the documentation of track, some sample, so that you can, because my sample only for image classification and face recognitions. Yeah, you may go and view the track sample. All these they have furthermore sample for you to find out, right? Mobile bird example, all this, so that you can have more features that you can implement by yourself. Okay. Next, I will show you how the face recognition works. Okay, let me go to the face recognition. So stop and start a new one. Oops. Clock expiring. Let me restart. Okay. These are another samples. I already download. So this is a sample different with compared to the image classification. First, it built a canister, it deployed the canister without the models. After that, it only upload the models into the canister. So the implementation is slightly different. So you check the backend code, it has the another storage function. The same, it has the stable storage, it has a ORC preview, track ONX. So this storage, so they implement a new storage function where try to simulate the file system in the canister. That means when you upload, you can upload a chunk of files bytes and calling this append byte with your file names. So it will simulate by using the standard file system, open the file and append the file, append the content into the file. But actually, this is not the actual file. It is a storage within the stable region. That means it's stored into the stable memory in the canister with a specific name. So the ONNX basically is doing the embeddings and detect the face and recognize the face. So lib is an entry point. So you can check the interface. What is the expo function? So this is the function how to upload the face detection model and face recognition model. This project, sample project, has two functions. First, and using two models. One is to detect the image whether has a contains a face in the image. Second, it will recognize, do the face recognition. You can upload multiple image with face into this canister. Later, you can use the face recognition function to match back the image has been uploaded previously to measure it belong to which image. Okay, how to build the project. Okay, so there's a README. Later you can try yourself and follow by all the installation. I already installed the models. So you can see, I already download the models. Face recognition model, and this is a face detection model. So I already download the face detection model. So face detection model, you download from here. Then you need to install the Pythons and this PyTorch because they are using this VGG phase 2 face recognition model, but unfortunately, this model is not in ONNX format. So you need to run this, create a Python script, run this script, you will download this model and convert into ONNX format. Because since we are using the track AI engine, which only support ONNX format and NNEF format. So you do this conversion so that you will have the face of ONNX format is about 93 megabytes. So then how you upload, you need another tools. So this tools IC file uploader will send the models, will open the files and send the data into your canister by calling this append face detection models. So if you later when you build your hackathon project or you a project related to AI in your canister, you can have similar implementation. How to upload a big files into your canister. Okay, let's start. I already run all those, so let's deploy the. So it actually is the same. It has also a build file where you also need to, once it's built the WebAssembly binary file, you also need to convert whatever's within the WASI function into ICP function. So this two sample is on-chain inference. That means you are running models in the ICP canister. So later when after you already deploy the backend canister, when you start to use this function, this IC file uploader to upload your models, if your current identity has password to unlock, unfortunately, this file uploader not support your identity, your DFX identity with password lock. It won't able to use the identity with password lock. So make sure your DFX currently is using an identity without password. So this is still very new and early. So that's why they don't support identity with password. Okay. That's why I'm using an identity has no password, so that it will successfully use my identity to upload the files. It unable to submit the password when called, because internal the IC file uploader is calling the DFX function. It unable to submit password to the DFX. Since if your identity has password and it unable to submit the password, it will fail calling the DFX function. Okay. Time to upload. So this is the content of our models. So first, it clear whatever models in the canister. It just clear, because next time you can use the different new model. If you found any other model working better, you can clear it and upload the model that you choose. Okay, let me run. So if you are using identity locked with password, this will fail. You will see the error message. Say it unable to open the PEM file. So when upload into the back end, it will split into chunk. a few megabyte per times. So you will take some time to upload the big files. Okay, so now you already have two models in the canister. One model responsible for face detection, another model responsible for face recognitions. Okay, once you have that, then you can start the front end. Okay, so now need to add. I can add my face in. I can add my face in. Add person. Okay, so it calling the face detection. So you can detect the photo has face. Add another person. Okay, add someone. Okay, so I add right now. I add the face into the canister. Means I store all the face into the canister. Then later I do the recognitions, capture the current face. So let the smart contract recognize. Yes, it's able to detect Francis Hall because there is already register a face in the canister, and there is a confidence score, so that you can use this method to register many face into the canister, and you use blockchain to keep track the face data. So this is how the face recognition works. So it already give you a sample so that you can refer to this all this face recognition to implement your own face recognitions application. It can be the object recognitions, it can be any detections, right? Image detection, video detection, all this by using the track engine and the correct models. So you can still find from the ONNX model. You can go and find from the ONNX model what are the suitable model you want to implement in your applications. So that is the two sample demo how you run a AI model in the smart contract by using track ONNX and built by using Rust programming language. Next. So once you enter a sample, so you need to have a dependency. As I say, if you follow a demo, you need to have WASI to IC converts all the WASI function to sub into emulate the ICP canister emulate function, so that you can build it, deploy in ICP without any problem. Okay, next, now we come into another hot topic about Gen AI. A lot of people have been talking about LLM. LLM is a large language model. It's a type of computations model designed for natural language processing tasks, such as language generations. So LLM has the ability by learning statistical relationship from the vast amount of text during self-supervised and semi-supervised training process. Due to current limitation of canister, the max ICP only able to support a small LLM model. The parameter supposed below 500 million parameter, which while above 500 million parameter, you won't able to run in ICP canister at this moment. Below are the some LLM engine supported by ICP. Number one, that is called ICPP underscore LLM. It's an LLM for internet computers. So you can go to here. So this is one of the LLM engine. This one of LLM engine is converted from another engine written in C programming, C++ programming. And also another one, quite a famous LLM engine called Llama CPP, a C++ inference engine, a C++ and AI engine support LLM. Then only CAI, this user converted and port the Llama CPP as in a canister. So we will done. So you can visit here, you can check it out how to build. But to build this, to use this engine to build this and compile, at this moment, you only can build the canister on Mac. So like me, I'm using Windows and Linux, it won't support. It will be failed. It will fail. And this engine is using CBA can using another model format called GGUF. Later, I will show you those model in Hugging Face. Which model, when you use different type of LLM engine, you need to understand what type of model format is supported, or else you loading the wrong model format, it will fail. If you fail to load the model and run the models, so can only build the canister on Mac. So there's a demo project. There's a demo project here. So you can refer to here, and this is a sample. This is a demo, is already deployed. So you log in with internet identity. So they are loading with Q1 2.5, or you can choose tiny story, even smaller. So there are different fine-tune type. So this one 0.5B means it's 500 million. So you can try. Okay. Since it's calling on chain, basically they are using the Llama CBP canister. So it takes some time to process. So you go to the source code, all this, basically it give you a dependency, how to do the installation, everything. So it has two canister. One is ICP-RM, another one is Llama canister. So ICP-RM, they are using the models for the tiny story models. They are using the tiny story model run inside the ICP-RM. Then for the Q1 one, they are using the Llama CPP canister. Yeah, the Q1. Let's see. Yeah, it's still, yes, at this moment, due to the constraint of the canister resources, running a bigger model, example like 500 million, it will need to take time to generate. You will still need to take some time to generate to get the response. Maybe in future, like example next year, ICP node will upgrade with GPU feature. That time it will be respond faster because right now all the canister run in CPU. So whatever inference process are using CPU. So that is the reason the processing and response is slow. But at least we showcase we are able to run LLM models in canister smart contract. So there is one of the this a few LLM engine. Another one engine you may also need to look into. This called Candle. Candle actually is a new LLM engine, a minimalist machine learning framework for Rush, which focus on performance and it built by Hugging Face. The best is Candle ML framework support multiple models. Example like multiple model, that means you can use this framework for vision recognitions or LLM. Example like Whisper, Phi, Meta Llama, Google Gamma, Stable LM, Mistral, Q1, and etc. So originals you can so you can try it out without the canister first. Then later you will try the pod version. So from here, then there's a lot of dependency, and you can see from the candle it will tell you this engine, what are the model is supported. Like object recognition, you can do using your YOLO engine, speech recognition by Whisper, Llama. This is a Meta Llama version 1, 2, 3 from Facebook. Text generation, the smaller models. Fine, this is from Microsoft, if I'm not wrong. So there are a lot of supported. So Q1 is the from Alibaba, but some of the model is very big, so that it not able to run in ICP canister. So you have to choose the right model to use. And there's a lot of example. You can refer to this example, and it will help you how to port it into ICP canister. Different model has a different way of writing, using different way of using the different way of implementation. Example like Llama has a Llama implementation. So you can refer to the code. Llama implementation, how they implement the tokenizer transformer function. So you need to follow, or else there's not a standard way of implementation like QN. But the sample code is get ready that of 80% of the code, how you're able to port into ICP compatibles. So this is a QN method of implementation. Although using the same engine, but the way of implementation is different because each different model has a different parameter. It's still coming up. Okay, you can see the responses I type in. Okay, so Candle, I will say Candle will be the next AI engine for Rush. And thanks to the LDC Labs, it's also port the Candle's ML framework to support ICP. So you can find out here. You can find out here. So it has some slight modification, but it's been behind for a few months. Maybe your end can also look into how to upgrade this with the latest Candle codes, because it has been behind 150 commits. So I believe it should be a few months old already, the codes. Then it also has one demo, how to implement a Candle by using Qwen. By using Qwens, they call IC Panda AI. So this is something. So they're using Qwen 0.5B. The max it can support. So implement the check. Yeah, they are using candles. You see the candles code. Okay. So other than if you want to do inference on chain, you also have other option, alternative that you can inference on local device. If the user trusts their own device, they can trust that the inference run correctly. What it means inference on device? It means you can use ICP canister to host the model, but the actual LLM processing, the inference processing, is run on the user device. Example, in the user browser. So this is one of the demo project called DaVinci. That means it pull the models from, it can be from ICP canister, it download the model. How to upload or store as in ICP canister, just now I already show you, you can use ICP file uploader, or in previous workshop, I'm talking about asset manager canister. You can use the asset manager canister function to upload the model files. Then you are able to download the files from the canister via the URL, the canister URL endpoint. So you can use this implementation. Then how to run the inference in the browser? You can implement this web LLM. So this is a web LLM code. You can check out how to run the web LLM. So that means you will run the inference processing in the user browser. So this is supported models like Llama, Pi, Gemma, Mistral, Human. So by using this method, you will able to run the inference much more faster, but it will take time to download the model into the browser local storage. Since you are running the model in the on-device, the user browser, if the user browser has support GPU, the device has GPU, they able to use the GPU like web GPU, all this. That means when the inference process will respond faster and you able to support a bigger model like 2 billion parameters, maybe up to 7 billion parameter, depend on the device specification. Whether the device has GPU, type of GPU, example like NVIDIA 4000 series, which has 24 gig VRAM, all this, they even can run a bigger model. But it need some time to download the models, because like example 4B, it will take about 3-4 gig of model files to download. So this is another example. So you can use this method, and then you build a canister to store the chat history, means all the conversation, whatever prompt that you submit, and the prompt that respond from the AI models engine. You can store those into your project canister to keep track the transparency and how the AI model respond. So this is a sample. This is a link of the sample. You can check. So you can see, you can choose. So there were some small models. Yeah, so it faster. So I click, so it download. So I start downloading the models into my local device. Then I can connect to my internet identity. So basically the whole inference process is run within my browser. So this is some of the sample that give you an idea. You may not compulsory to build fully on chain. The inference can be on device. So if you really want to implement ICP inference on chain, so you need to search for those model that is below 500 million parameter. Example like Asmo LLM, which trained by Hugging Face. It has a smaller model like 135 millions and 360 million, but it is based on Llama. If you are using, just as I say, if you are using Candle's ML framework, you need to modify the codes. You need to use the code that for Llama. Yeah, you need to follow this sample code to use to run this model. So Hugging Face is actually a good place for you to search a lot of different models. You can check how big the files. So 265 meg. So actually they have a bigger models. So the model, so it depends on the LLM engine you are using. For Candle, you will use without any specific format. It's 360 without it. So just now got one engine, the LLM CPP is support GGUF. It use GGUF. Then if you want to have run this, you need to find all the model end with GGUF. GGUF, you see, GGUF. This is a ONNX model. So ONNX model normally used in track and also the web LLM. The web LLM is using the format of ONNX. They are using ONNX format. So you can search for a lot of different models like Llama, like Gemma, all this. So you may find out more. You can, for those who able to find out more smaller model which is suitable to do inference on chain, please do share in the group. This is something that I find out. Okay. Next, other tools. File uploader. Yeah, you can find out how to up. So this is one of the tools to upload files, upload the bigger file into the canister. Another implementation, someone is implement something like object storage service, like a S3, emulate the AWS S3 for you to upload bigger file into the canister. You can find this out more. Okay. Last is, if you want to find out more about the ICP Decentralized AI, please do visit this forum. There's a technical working group. Yeah, so that you can find out more about the latest about information news about decentralized AI. And another one you may also need to look into, if you experience on building LLM orders, you may know what is RAG embedding. That means by using the existing AI LLM model, you can upload your document, your own data into the AI models and let the AI model analyze your own document and data and respond to your prompt. So in behind, you may need to implement vector database to perform such function. As in ICP, there are several projects. They are building a vector database run in a canister. So those are some of the vector database project in ICP. Okay, so thanks for everyone participate in this workshop. So that is my today sharing about decentralized AI. Hopes you all get something back and learning how to implement decentralized AI in ICP. Please do join the groups And here is a presentation slide. If you want to access to it, then please fill up the feedback form if you need a cycle to kickstart your developments to deploy your canister in the ICP mainnet. Thank you, everyone. So anyone has any questions?
Thank you so much, Francis. I really hope, like, you know, that was a really great workshop, right?
Yep.
So, like, you know, for anyone interested in, like, you know, working in the intersection of blockchain and AI, right?
Mm.
So, thank you so much for joining, right? And please, if anybody have any questions, right, or you wanted to join this group, right, I think you can join the group, right? And I also ask, we have this Scouts group there, right? We
Mm.
have posted our earlier workshop links as well, right? So you can watch them as well. This third workshop is also getting recorded. We will be posting this also. So all the three workshops are recorded. So you can revisit them. It's a very detailed, and I think anybody, like, you know, there are very less number of resources available in terms of our, like, you know, very wide coverage that Francis have done, right? I think this is one of the best workshops in terms of development wise on ICB, right? So everybody should take full, like, you know, advantage of this, right? So if you have any questions, please raise your hands, or you can drop into the text box, or if you wanted to, like, you know, ask any question later on, right, you can join the group as well.
Yeah, you still can ask inside the Telegram groups.
I think we are good. I think we have any questions.
Okay.
So I think we are good to go, right, Francis? Or is there anything left?
No, that's all.
Okay. Thank you so much for, like,
Okay,
you know,
thanks.
coming on to the call, right? Thank you everyone for joining us.
Thank you, everyone.
I think we can wrap this up, right? Thank you so much for joining.
Yeah, okay. Bye, everyone.
Bye, bye everyone.